In this lesson, we're going to start learning about matrices, and one use of a matrix is to organize data that's in a table. So here's some data. If we had grade levels maybe in a class of the 9th, 10th, 11th, and 12th grade, and then we could keep track of how many calls, pictures, or text they used in a day. So we have the rows are representing grade, and then the columns are each of these. This could be put into a matrix just by copying all of this, and we would write these numbers, just copy them. And then we go like that. So we're going to be working with operations on matrices, and a lot of what we do will just be you're given a matrix, and then you add, subtract, use multiplication or division. And we have the this matrix. We could talk about its dimension. Its dimension is the number of rows times the number of columns, and so this one would be horizontal numbers are rows, and the verticals are columns. So this is going to be a 4x3 matrix. And then we can talk about an element. An element of the matrix is one entry. So if I said element 2, 3, that's row 2, column 3, row 2, column 3, 170. Or we could say element in 3, 1, so row 3, column 1, 15. And we could say element in 3, 2, row 3, column 2 would be 7. So here the dimension of this matrix is going to be 2 by 3, 2 rows by 3 columns. So the dimension of A is 2 by 3, and element A22 is row 2, column 2. 1, 2, 1, 2, so it's right there. That is that element. And you try this one. So the dimension of B is 1, 2, 3, 3 rows by 1, 2, 2 columns, and element 3, 2 is 1, 2, 3, 1, 2, negative 8. Alright, and here we're going to use scalar multiplication and matrix addition. So 3 is a scalar. That's what we call numbers that are not a matrix or a vector. So when we multiply the matrix by 3, we just make sure we multiply each element by 3. So by multiplying, we'll go 3 times 2, 3 times 1, 3 times 0, 3 times negative 4. And then we can just add the corresponding elements. 6 plus 4, 3 minus 7, 0 plus 10, negative 12 plus 12. Alright, and pause the video, try the next one. We could multiply by negative 2, or we could just multiply by positive 2 and keep the subtraction. So I kept the subtraction, and here 2 is a scalar, and now we just subtract the corresponding elements. 6 minus 10, negative 1 minus 4, 2 minus 0, 3 plus 2, and 0 plus 6, 4 minus 0. All right, and in the next example, we're going to be looking at one more requirement for the addition or subtraction of matrices, and that is, this is a 2 by 2, and that is a 2 by 2. If we're going to add or subtract, then these have to be the same. Here we have 1, 2, 3 by 2, 3 by 2, and this is 1, 2, 3 by 2, 3 by 2. If they have the same dimension, then we will be able to add or subtract. So if we try to add these matrices, we could multiply by 2, but now we have a problem. There's nothing corresponding to this, and we have, this is a 2 by 2 matrix, 1, 2, 1, 2, 3. So if the dimensions aren't the same, then we can't add. Oh, and then we have to do 2p minus q, and here will be, let's do 1/2 p plus q. So more of the same, addition and subtraction, just a little different way of asking the question. So with this one, we can have 2, then we'll copy p, So we can do the subtraction, and then we will multiply. So 3 minus negative 4, that's going to be 7. 8 minus 5. Negative 2 minus 7. Negative 5 minus 3. 5 minus negative 10, so that's 5 plus 10. Negative 4 plus 6. And then just multiply by 2. Alright, and pause the video and you try this one. 1/2 p plus q. So we have 1/2 p plus q. So we'll do the addition and then multiply. 3 plus negative 4. 8 plus 5. Negative 2 plus negative 2 plus 7. And then we'll go negative 5 plus 3, 5 plus negative 10, negative 4 plus negative 6. Multiply everything by 1/2. So in this problem, we're still going to be using operations with matrices, and it's just another way of asking the question. Here, x represents a matrix. It's not just one number. So we're going to go 4 times some matrix minus b is equal to a. 4x minus b is equal to a. And so now we want to get x by itself. We're going to add this to both sides. So then we'll just have 4x. We'll combine these to get 2 plus 1, 0 plus 3, negative 3 plus 7, 17, negative 5, 10. And now we need to multiply both sides by 1/4. And we'll just multiply everything by 1/4. And 10 over 4 will reduce to 5 over 2. And pause the video and try that one. So we want to subtract that from both sides, and we're trying to get x by itself. 1 minus 2, 3 minus 0, 7 minus negative 3, that'll be 7 plus 3. 12 minus 5, negative 3 plus 2, 6 minus 4, 6 minus 4. We want x by itself, so we're going to multiply by 1/3. And we'll have negative 1/3, 3 times 1/3, 10 times 1/3. Last example. And here we could have variables throughout each matrix, but if the matrices are equal, then we know that 2x is equal to 5y. And we know that y is equal to 6. So that means we have 2x equals 5 times 6. And pause the video and try that one. We have x is equal to 2y, and 3y is equal to x plus 1. So if we have x isolated, then we could put 2y in place of x. 3y equals 2y plus 1. Y equals 1. And x equals 2 times 1. So I hope you enjoyed this nice break from trigonometry.